In this video, I will present the mathematical models that go with work and energy. So first, work. Work is symbolized by a capital W. So work is force times the distance an object moves times the cosine of theta. This theta is the angle between the force vector and the distance vector. Notice neither one of these has a vector symbol on top of them. So this is the magnitude of the force, the magnitude of the distance moved, and then the angle between those two vectors. Then we have kinetic energy. Kinetic energy, we'll use a capital K for kinetic energy, and kinetic energy is 1/2 mv squared, where m is the mass of the object and v is its speed, which is just the magnitude of its velocity. You can see that kinetic energy can never be negative because mass can never be negative. Also, speed can never be negative. And if it could be negative, you're squaring it anyway. Work is related to kinetic energy by the work energy theorem. So the total work done on a system is equal to the change in the kinetic energy of that system. Now I say here to be careful about how you use this, because when we use potential energy, sometimes you can think of potential energy as being a change in energy over here. Sometimes you can think of it as being a source of work. So it can appear in different places. So be careful about this. If you're looking at just the change in kinetic energy, you need the total work done by external forces, including potential energy, when we get to that. And finally, we have power. For power, we use a capital P. So power is work per time. And it can also be force. This is not the force vector again. It's the magnitude of the force times the speed times cosine of angle theta, where again, theta, the angle between the force vector and the velocity vector. And as I said in the concepts for this chapter, power can be work per time or change in energy per time. And look, work is a change in energy. So this could be a change in energy over time as well.